Hi students, so we are going to go ahead and work on the next part of our investigation, which is going to be focusing on making predictions. Okay, so at this point we should have already completed our hypothesis and variables section, and we're working on the making predictions. And to begin, I want to go ahead and present our PowerPoint, and I just want us to think a little bit more about what exactly are we doing in this investigation. So let me make me a little smaller here, put myself in the corner. And we're going to go back a few slides here. And what I want us to do is I want us to just shortly read through our investigation procedures. So I'm going to pause the video here and I want you to read through exactly what we're going to be doing when you watch our investigation that we'll conduct tomorrow. Okay, now that you've had a chance to read through, we're going to go ahead and work on making some predictions. Okay, so I'm going to click through to this slide where it says we're going to get ready to interpret our data. And I want us to think about, in this next section, if we made a graph of our data, because in here, we'll be collecting data regarding how much force is produced when there's an attracted magnet at a certain distance versus a repulsive magnet at a certain distance. And we want to show what that data looks like in numbers, but also we want to be able to graph that afterwards too. So when we graph that, I want us to think about what would our graph look like if the data supported a hypothesis, and what would it look like if our data did not support a hypothesis? So you'll notice that on our document we made a copy of, okay, so this is a document we worked on in the previous task. Down below, I have two graphs for us in this section C where it says making predictions. And in these two graphs, we want to go ahead and show what they would look like for, on the left one, when our hypothesis is correct, and on the right one when it is not correct. Okay, so before we do that, let's remind ourselves what a hypothesis is. So take a moment and read through a hypothesis. And you'll see that a hypothesis is that if distance affects magnetic force, then we move two magnets closer together and further from each other, we should observe the force on the scale changing. Well, how are we going to show that on our graphs? Now, unfortunately, you won't be able to draw on your graph in Google Documents. So what I'm going to ask you to do is while I draw it, I want you to type right above the graphs in this section. So if our hypothesis is supported, we should see that these numbers change, okay? And if we assume that our y-axis, the up and down portion, if that is force and the x-axis going across is the distance, that line should change, all right, in a certain way. We may not know what that change is yet, but it should be changing. So on here, we need to type that the line should be changing, and it should not be straight. What I mean by that is, if I take my pen here, notice how if I draw my line like this, notice how that line is changing, all right? So that if this down below here is our distance, and it's going to be kind of hard for me to write, so I'm going to just put a D for distance. And if this up and down over here is our force, notice how that as we increase our distance, notice how our force might be increasing as well, right? And notice that's always changing. Now, let's think for a moment that, well, what if, and so on this one, we'll want to tab over and get to this graph. What if our hypothesis was not supported? What should our line look like then? Well, think back, if our hypothesis is that our numbers are going to change, we should see our numbers stay the same in this graph. Okay, so the line should not be changing. Therefore, it should be straight. And we've seen what straight lines look like in math class. So what that would look like is at a certain distance, there should be a certain force. And it's going to be hard for me to draw a straight line here in my computer. But notice how this line is straight. It should not be changing. Okay, therefore, no matter what distance we're at, right, no matter where we're at on this line, that force stays the same. Therefore, it would not support our hypothesis. Okay, so on your document, I want to make sure that you have these two things typed, because if these two things aren't typed, I'm not going to be able to give you a good grade on that portion, because I know we can't draw on the graphs, but we should be able to type what the line should look like. Okay. All right, so that takes care of the portion of our handout where we want to make our predictions. Okay, and that now concludes this video. So at this point, you can move on to your next task, which should be the exit ticket. And then from that task, we will look forward to doing our investigation tomorrow.